Today, I have something new that I'm excited to share with everyone. So if you guys have actually created a Kaleido account before and you've logged in over the last 10 days, I believe, you'll see that we have version 2 of the Kaleido console with some fantastic updates to the navigation, some new functionality around metrics and monitoring, and some new components as well. One of the new things that we added over the past few weeks is the ability to delegate your Ethereum signing to private keys that are held in a cloud HSM, such as AWS KMS or Azure Key Vault, or even using HashiCorp. We've created basically a fork of HashiCorp and open sourced a signing component that allows it to not just be a key storage utility, but to actually sign using the Ethereum curve. And so we have all 3 flavors of those inside of Kaleido for what we call cloud HSM signing. And that's what I want to show today. And we're going to actually use Microsoft Azure Key Vault as opposed to the AWS services, which I typically show. So I'm trying to be equitable, showing both of our cloud providers that we offer on Kaleido, not preference one of them over the other. So the way that the cloud HSM signing works is there's 2 flavors of it essentially. Obviously, the private keys corresponding to your Ethereum account are going to be held in that piece of hardware. But you have the ability to submit the object in one of 2 ways. You can go the classic Ethereum route using WebSockets, using RPC, and essentially create that unsigned transaction object with proper RLP encoding that will be intercepted, right, by this shim proxied into your AWS KMS system, Cloud HSM, or your Azure Key Vault system, and then submitted to the network, right, turned into an unsigned transaction object and then a raw transaction object submitted to the network. The optional second approach that we have, which we've looked at this, in deep detail many times, but those of you that have attended these will know that I'm quite favorable to this piece of functionality in Kaleido, is using our REST API gateway as the submission layer, and this is basically our piece of middleware in Kaleido that removes all of the Ethereum complexities, including RLP encoding and the sequencing or nonce management requirement. And you have the ability to, using a parameter inside of this service, KLD-from parameter, where you're enumerating the Ethereum address that's going to sign the object. You can leverage all sorts of different techniques in Kaleido. So you can have that private key held on the Ethereum node, on your Kaleido node. You can have that private key held in sort of a ancillary Ethereum wallet service that we call ETH wallet. You can use an HD wallet service. This is fantastic for if you're doing, end user management, account management for hundreds or maybe thousands or hundreds of thousands of end users. Super easy to integrate with your OpenID LDAP systems. Just create a mapping to the HD wallet and your end users. And then the 4th or 5th flavor of that is to keep those keys off platform. Keep those keys in a cloud HSM or in a HashiCorp Vault server running in your own private cloud or running in your own data center. And all of those objects, again, are going to get assembled in there. The key will never leak from that piece of hardware, and then they're going to be submitted into Kaleido. And all you do basically when you're writing your node application, the from address just needs to be the corresponding address that's inside of that HSM. So like I said, we're going to look at the Azure Key Vault approach here. We'll go into the Azure portal. We'll create an app registration. We'll create a Key Vault. We'll give our Key Vault access to our app. And then we'll go ahead into Kaleido and we'll create the accompanying configurations and the actual HSM service. And then we'll finish by hopping into our REST API gateway, and we'll use that account that we created to actually sign a few transactions. A few other folks have joined, so let me just get everyone off of mute. To the late arrivals, I'm just unmuting everyone, so if you want to chime in and participate interactively, also feel free to use the chat. Okay, so first thing we're going to do is we're going to go into the Microsoft Azure portal. I know most folks here are either going to be, I guess, a little a little specifically drawn towards either AWS or Azure. Not a lot of folks have existing estates, crossing clouds. But for the folks with Azure using AD and using key vaults and blob storage, this will be a good walkthrough. And we have focused on AWS primarily in the past, so this is good sharing across clouds. So the first thing we need to do, Azure Active Directory is kind of the baseline component that a lot of the other services are derived off of. This is where we handle our permissionings and our registrations. Inside your Azure Active Directory, you're going to create what's called an app registration. And the IDs inside of this app registration and the secrets are what Kaleido is going to use to authenticate to your HSM, to your Key Vault service. These will be the user IDs, the secrets, the passwords, the API keys, etc., that our service is going to need in order to securely access your Key Vault service where that private Ethereum key is held. Okay, so app registrations, this is incredibly simple to do. All you need to do is create a new registration, apply a name to it, and then this is going to auto-generate you some of need. We're specifically concerned with these three strings right here: the client ID, the tenant ID, and the object or the subscription ID. Okay, I have these already configured into my Postman calls, but these are what you're going to be concerned with when you're ultimately integrating this with Kaleido and with your Key Vault service. The next thing you need is an actual secret, right, to authenticate to this registration. So if you use this certificates and secrets button right here, you're going to create a new client secret that's going to authenticate you to that app registration, and then that app registration is going to have a permission or a policy to your Key Vault. I've already created a secret right here, U?8, and that as well is configured into my Postman calls. So those are the first two steps that you're going to want to take as you're going through this flow with Azure and with Kaleido. Create an app registration, give it a nice human-friendly name that kind of defines what we're doing here, Kaleido HSM signing. Go ahead and create a secret, and then we're going to create a Key Vault service, and we're going to give this app registration some policies and some permissions against that Key Vault service. Okay, so we'll go back to home and we'll go to our Key Vaults here. I was messing around with this earlier this morning, but it looks like I've been able to delete all of mine. So we're going to create a Key Vault. So it'll take a few seconds to come up. And first, we're going to go ahead and bind it to an existing resource group that we have right here. Now we're going to give it, a nice friendly name. I'm going to call mine Kaleido Keys right here. This again is going to be an argument or a parameter that looks like I've already used it. How about Kaleido Keys #1? Okay. I have a soft delete enabled, so it's not actually fully purging some of the resources I've created. In any event, you need to have a nice name for your Key Vault. This is required by Kaleido as well when we go ahead and create that configuration object. Choose the region where you want your vault to be, your pricing, etc. Do you want soft delete enabled, and the retention period here. Okay, so very, very standard, very easy to do. This next one, the access policy, is a little more interesting. So go ahead and click next on the access policy, and we're going to need to create a new policy. And there's 4 permissions that this policy is going to need here. It's going to need 2 key permissions. It's going to need a get and a list. And then for the crypto operations, it's going to need a sign and a verify here. Those are the 4 permissions that are required from Kaleido in order to properly access these keys and to do the asymmetric sign verify operation. Okay, so go ahead and leave those 4 enabled. I'll also mention that we have pretty thorough documentation on all these steps. So it's great if you're paying very, very close attention to this, but using AWS or using Azure, you simply just need to follow along with the docs, and we'll walk you through kind of the KMS permissions that you need and the crypto permissions that you need, and then how to basically bind your app registration to this custom policy that you've created. And I'll get to the questions in the chat here momentarily. So we created those 4 permissions. We don't need secret permissions. We don't need certificate permissions. But this is the critical piece right here, the principle. This is where we're going to bind this policy to our app registration, our Kaleido HSM signing app registration. Okay, so we'll go ahead and search for that. And here's our app right here. And definitely go ahead and click select. Sometimes, you know, I guess the supposition is that, you know, this, as soon as you click something, that it'll automatically persist. But I've learned this the hard way in some of these cloud providers, that oftentimes you have to click save or you have to click select manually. Okay, so we've bound our app registration to this custom policy that we've created, and now we're going to go ahead and add it. And now we see here that we have our Kaleido HSM signing that's bound to this key vault instance. Okay, so we're going to finish by creating our key vault here. And this will take a handful of seconds to configure, to validate, and now we can actually create it. So I'll get to the question in the chat while this is deploying. Oh, bad connection. Okay, sorry about that, Henry. If for some reason my internet is choppy, or if you guys are unable to hear something or need something repeated, just chime up or throw something in the chat and we can go back over any of these concepts or steps. Okay, so our key vault deployment has been instantiated. Now we can go to that resource and we can go ahead and look at our access policies, and we see that we successfully bound our Kaleido HSM signing policy to our key vault. So awesome. So we can click overview. This is going to give you some nice metrics on sort of the connections that are coming into your key vault, the number of times that your keys have been used or accessed. This will be more interesting when we actually make a call from Collido to use one of these keys. But in the meantime, we actually need to create a key. So Azure and AWS and HashiCorp, thanks to our open source extension that we added, they all support the Ethereum curve right now, SecP 256K1. This is a new addition to, I think over the last 12 months or so, to both AWS and to Azure. I believe Azure had it first, and AWS added this functionality within the last year. But the idea there is, since they support that elliptical curve, they can support Ethereum signing as well. So we're going to go ahead and create just a single key for the time being. This could be a key that, you know, represents an organization. It could represent an end user, represent a department, etc. We'll just call this Kaleido user 1. Right? Any arbitrary name that you want to basically define this key right here. We don't want RSA, we want elliptical curve. We don't want prime 256, 384, 521. We want the Ethereum curve, SecP 256K1. So these are really important here. Make sure it's elliptical curve, make sure it's the Ethereum curve as well. Make sure it's enabled as well too. And then just go ahead and create that key. And this should, you know, take a few seconds to actually generate here. So here we see basically the ID and the version, and behind the scenes, using a Go library, when Kaleido makes a call, you know, to this, there's going to be some, basically we're going to be able to derive, you know, the X and Y axis and generate that public Ethereum address. I don't want to get into the low-level EC recover cryptographic operations of how that works, but it's just using crypto primitives, and this value, along with some additional X and Y values that Azure is going to supply, will allow Kaleido to derive the Ethereum address that corresponds to this key with this curve right here. If you guys are interested in more details on the low-level nuances of those crypto ops, feel free to open, you know, drop me an email, or you can open a support ticket inside of the console. We'll have one of our crypto engineers get back to you on that. But in any event, I say that because this can be perhaps a little confusing when you say, hey, I used the Ethereum curve, I created a key, but this doesn't look like an Ethereum address. This doesn't look like a hex string right here. And it's not, right? This is just this is a resource ID that has some associated X and Y values alongside of it that will ultimately allow an Ethereum key to be derived, to be generated, so to speak. Okay, so we've done the heavy lifting inside of Azure here. We created our app registration, we created a key vault, we added a custom policy, and then we bound our app registration to that policy. Now what we want to do is, using all of these values that we just looked at, our app registration, client ID, tenant ID, subscription ID, along with our key vault name and our client secret, we want to create a configuration object on Kaleido. So what I'm going to do is I'm going to shrink this a bit, or a lot. And here I have my Postman terminal open here. And just to give you guys context of what we're pointing at here, I've created a single, all right, let me open this a little further. I have a single consortium inside of Kaleido. I created a single environment. Of course, it's going to log me out. And I have 2 nodes inside of this environment with Geth and proof of authority. And what we're going to do is inside of this environment, we're going to create a configuration object for our Cloud HSM service, basically teaching this configuration object about our app registration and about our key vault instance. Once we have that object, we're going to bind that object to the HSM service that we create. So the necessary endpoints that we need in Kaleido when we're making this post call, essentially, we need our consortium ID right here, 50V. We need our environment ID right here, JT4. And particularly importantly, we need our membership ID, right? This key vault service, this HSM service is not shared across the consortium. It's not shared across the environment. This is the utmost level of security and end user ownership. So this is fully bound to a membership ID. My guy is REC here in this iteration of my consortium. And this is in contrast to other services that we have, such as, for example, the Ethereum Tether service, or a ID registry service, or an Ether pool, or a Chainlink faucet, basically, right? These are shared across your environment, across your business network environment, but business network as well. This is not. This is completely private, completely unequivocally bound to a single membership. So Kaleido is looking for all of those arguments here. So what we've done is we're taking our, we'll just scroll over here again. Just bear with me as I keep hopping back and forth between these windows, but I want the relationships to be clear here. Okay, so here's our Azure service, here's our app registration, and here's the call that we're going to make on Kaleido. So what we're doing is we're sending a post call to our environment, right? We're specifying our consortia ID, our environment ID, and we're calling the configurations route, okay? We're going to provide it as a type of Cloud HSM. This is an arbitrary string here for name. This is just defining your configuration object that you're creating. This is your membership ID, right? This is what the object is going to be bound to. And then these are kind of the gnarly pieces. These are the details, all right? So mine was called Kaleido keys. What did I call it? Did I call it 1 or did I call it -1? Hang with me. Let me make sure I don't get this wrong. All right, I called it just 1. Okay. All right. So these are all the, basically all the arguments that you need to supply to Kaleido when you're creating this object right here. So the first one, bearing with me, we need the application ID, the client ID right here, the user ID. So this is A1106, right? A1106. Then we need that user secret, right? Which, remember, it's not going to be shown to you. It's like an app credential in Kaleido on Azure. They're going to show it to you one time, and then you are responsible for the custody of that secret. So they showed me U?8 for my user secret. The subscription ID, that's the object ID right here, B98, B98. The tenant ID, EB2, EB2. The vault name, Kaleido keys #1, which we just named, and then the target address. This is just the default endpoint to the vault service. Okay, so all of those look good. This is authenticated with a Kaleido administrative API key. This is not using application credentials. This is an admin operation. So we'll go ahead and send this call off, and this has now created us a configuration object. This hasn't done anything terribly interesting. All this did was this confirmed that all of our endpoints were accurate, that we were able to access it, and that we built out a configuration object right here that we can bind to our HSM service when we go and create that, okay? So again, this is all documented ad nauseum in a good way inside of docs.kaleido.io. Takes you through Azure, takes you through AWS, takes you through HashiCorp. Okay, so that's the first call, build out the configuration object. And this will be available inside of the console here as we kind of finalize V2 of Kaleido. So, you know, if you're not a root administrator and you don't love using your terminal or using Postman, this will become a bit less intimidating, I guess. But in any event, it's pretty much just a simple JSON object that you're calling here. So I'm going to call a get on my environment, pretty much the same thing we just did, and go ahead and get back the existing configurations that we have. And what I'm concerned with at this point is the ID of the configuration. This is basically the top level wrapper that has all of this information persisted underneath it. And we see that we're not exposing that secret anymore either, which is a good security feature. Okay, so we have our ID here. And the next thing we want to do is we want to actually create our Cloud HSM service, and we're going to pass it this ID so that it can basically ingest all of those details. Again, we need to use our membership ID here, and now we need to use that configuration ID that we just created in this step. So I'm going to copy this guy right here, and I'm going to pass him to the details parameter here. So this call now, similar to the other one, instead of calling configurations, we're calling the services route. So we're calling our consortium ID, our environment ID, and we're posting to the services endpoint with our membership ID, service of type Cloud HSM, and the ID, the configuration object ID that we just created. Okay, so we've sent that call. We see here that it's in a state of provisioning. And what we want to do is we want to see this turn to a state of live or a state of started here. So now what we can do is we're going to give this a few moments to initialize. And again, we see here that we're going to call a get to our services endpoint right here with our consortia ID, our environment ID, and we're going to actually ask for the status of our service here. So I'm going to go back. I'm going to get the service ID that we just created, which is this string right here. And we're going to ask for the status of our service. And when the service is started, what we expect to see back, are the endpoints that we can target. So we have just the raw HTTP endpoint that you can access the service at. And then you have the endpoints that you can call for signing operations for Web3 kind of calls. If you're using, Web3 JavaScript and you want to create that unsigned transaction object and get it signed by the key in the HSM, you're going to go ahead and make a call to, either the HTTP or the WebSocket endpoint here. I don't know. I was asking a colleague this the other day. I'm wondering, since we have the REST API gateway, why someone would choose to take the overhead of using kind of the client library Web3 route to do HSM signing. I know some people are, have hardened applications and are comfortable with those libraries, but you still have the overhead, of nonce management. Whereas if you're simply to use our REST API gateway, you don't have to deal with, any of those complexities. All you have to do is just enumerate the address that's inside of your HSM. So if someone on the call has a good explanation for why someone would want to take the Web3 approach with HSM signing versus the REST API gateway, I'd be curious to hear the rationale. Nonetheless, these are the endpoints that you would use if you are taking that approach. This is simply the endpoint for the service here. Now, the last thing we want to do is we want to, once again, use the ID for our service, and we're going to actually call our Cloud HSM. We're going to call the Azure Key Vault, and we're going to go ahead and get back the actual Ethereum address. And this is a post to the service ID, which is this guy right here. And we're going to actually say accounts/refresh. And this should return us back the key that's hiding underneath, that Azure, Cloud Resource ID. So again, This is API/v1, and rather than going, to the consortia, to the environments, to the service, you can immediately enumerate the service ID, and then just post to the accounts refresh. Okay, so here's our Ethereum address that we created inside of the Azure Key Vault service. And this is what we can use inside of Kaleido in that KLD from parameter to actually sign objects. Obviously, I only created, a single account, a single key inside of Azure. If you're using AWS, you're using Azure, you're using HashiCorp, you can create as many keys as you want for your end users. If it's an organizational key that, everyone's leveraging, you can have a single one. More often than not, you're going to want to have multiple key pairs. Okay, so this is the guy that we're going to sign with here. Any questions at the moment? Don't hesitate to hop into the chat or speak out loud. Okay. So we'll go back to Kaleido. I'm going to expand the screen again here. Click our consortium, and I imagine most people have seen this before, but what we're going to do super quickly is we're going to create a contract project. And we're just going to upload simple storage, call it SS. We're going to import it from GitHub. Here's our source code that we have right here. This is the same smart contract that we use, single variable, type unsigned integer. It needs a value to be passed to the constructor on instantiation, and then it has two methods, set and a get, and a redundant query, which is my favorite. So we take this URL right here, put it into our contract project. We'll call it version 1 of simple storage for this compilation, and we're good with all the other fields here. We'll let Kaleido auto detect the compiler in the version. So click compile. This takes 4 or 5 seconds, and then we'll be able to actually promote this source code to an environment. We'll have our Swagger interface, and we'll be able to use that address that we just looked at right here inside of the KLD from parameter. So I'm sure this is already compiled. Let me give it a refresh since it didn't auto-generate, and we'll promote this gateway to one of our environments. So I'm going to just use SS as a shorthand. We're going to promote these APIs into our development environment. Here we have a gateways. I called it SS. And now we want to create an actual instance, a smart contract deployment of this gateway. So we'll generate some new credentials, go ahead and open up the API, and using the root post method here, we can instantiate this smart contract. So this is the parameter that I keep talking about when we're using the REST API gateway. And we've looked at this in the past on a number of Tech Tuesdays where we've shown how to, create a locked account on an Ethereum node and try to sign with it, and it won't work. Use the Kaleido API to create an account on the node. Use the Kaleido HD wallet, to sign these objects. Use the ETH wallet to sign it. Today, we're going to do the flavor that we haven't done before, and we're going to use that key that is held in the Azure Key Vault. Could be HashiCorp, could be AWS KMS, and that's going to actually take this unsigned, JSON object. It's going to get transformed. It's going to get signed. It's going to get submitted to our network. So what we want is we want this guy right here. So go ahead and copy that. We'll overwrite this with that. 0x000. A lot of zeros to start with. Hope that's not a bad omen. And then we'll just give it the human-friendly name for this smart contract, SS123. And we'll instantiate it with 5 for Cinco de Mayo. So go ahead and click try. Again, you can do this programmatically just as easily as you can inside of this Swagger interface here. And we see that we have a transaction success. And if we look at the from address, we see that it was signed by a private Ethereum key held in a cloud HSM. And this is critical too, right? As you're making the business case to your clients or to your management, a lot of the requirements come around risk and they come around key custody. If you have a compelling answer that says, hey, we can leverage HashiCorp, this has been turned into a signing module as well, and we can have those keys held solely in our data center and still leverage the simplicity of this REST Gateway API, then you start to say, oh, wow, well, all we really need to focus on now is just some smart contract logic and a user interface. All of the security and performance requirements are absolutely checked off. Similarly, likewise, if you're using AWS KMS or you're using Azure Key Vault, the fact that those private keys are in a piece of hardware gives you the utmost assurances that nobody is going to be able to access those keys. It's really, really critical, and you have that complete audit trail of every time that key was called. So you have the ability to go back and reconfigure your service. You can change that client secret. You can go ahead and delete keys inside of your HSM. You can create new keys, etc. You have full admin root control over all of these operations. So really, really powerful, really, really extensible techniques that are available here for you with signing. So we can close out of that, and we'll see that we've created an instance of this gateway simple storage 123, and it was deployed by, again, our cloud HSM signer that we see here, 001, the guy that's held in our HSM service. Okay, so that's about 30 minutes on Cloud HSM. Any questions from the group or on the chat? Okay. The last thing I want to show, and we showed this last week, but I want to draw attention to it again, is one of our client drivers. So it's a utility we have called Kaleido Go that makes it very, very easy for you to essentially, test the performance, test the throughput, and test edge cases against your application. So you can create gaps sort of in your nonce management and in your sequencing. You can test the throughput of your network and a horizontally scaled application by standing up multiple workers, having those represent or mimic client applications. A lot of different techniques you can do here, or you can just simply do soak testing against the environment and against the blockchain to ensure that it has the underlying performance that your enterprise or your solution is going to require. And so I'll show you two approaches here. What we can do, though, is we can actually use that same Cloud HSM signing key that we just used to sign through the gateway, and we can use that in conjunction with Kaleido Go. So super quickly, we'll take a look at how that works. And I'll grab the chat first. Yeah, so there is already support for what we have called the question was, is there plan to add Kaleido support for on-premise machines? So at the moment, obviously, you can stand up a HashiCorp server on-premise. That's open source software with the extension that we built to make it sign. So you can stand that up wherever you want. We even have mutual TLS built in to that. There is currently a closed program that we have called Kaleido Private Stack that happy to discuss offline, but you can actually run a self-managed, basically Kaleido pod with all the containers that are necessary to fully operate an environment and a node in a private cloud or in your data center, and that will be able to securely tunnel back to an environment with nodes running on AWS or running on Microsoft Azure. There's a considerable amount of heavy lifting that goes into that, and responsibility of the end user and end administrator with regards to scale, high availability DR, just the proper port mapping and Kubernetes orchestration. But the technology has been proven. It is in a closed pilot phase, but happy to discuss that in more detail offline, Patricio. Okay, so back to what we were going to show here. I'm going to show Kaleido Go, this program. So what we wanted to show is we wanted to show the ability to use, again, that same key, or 0x000, and actually sign transactions. And to do so, we're going to use this RPC endpoint right here. We're not going to use the node endpoint. We're going to use this to intercept that call, proxy it out to our Azure Key Vault, get those objects signed, and get those submitted to the Kaleido network here. So what we'll need to do is we'll need to construct a fully qualified URL with app credentials against this endpoint here. So into my terminal, and bear with me as I hopscotch screens here. a little bit. We're going to say /, we're going to call our program. We're going to give it the path to our file, which unfortunately is simple storage again. And we're going to exercise the set method inside of it. We're going to give it, we'll give it the value of 5 again for May 5th. We're going to call for, let's do 10 transactions, and we'll do, we'll do 2 loops, and we'll use 2 workers. Okay, so all of these arguments here, if you just call Kaleido go-h for help, you'll see all of the different parameters, all the flags that you can exercise here. So first, we give it the path to the file. We give it the method we want in the smart contract. We give it the argument to the method. We give it the number of transactions, the number of loops that we want, and the number of, I guess we call them workers, but this would just mimic an application that you have here. Okay, the next thing we need is we actually need our node endpoint, and that's going to be that RPC endpoint that we looked at inside of Postman to our Cloud HSM service. Oh, you know what, guys? I screwed up. I can only use 1 worker because we only have a single account inside of our HSM service. Each worker needs its own unique account here. So we'll just use 1 worker. We're going to enumerate our account first, which is this guy right here. And then we have to do a little heavy lifting here for our node. So we want to say HTTPS : // and this is where we need our application credentials. So I'll cheat real quickly and I'll just log into node number 1, click connect, submit, and I'll grab these credentials right here. Okay. So we'll pass that, and then we're going to say @ and this is where we're going to pass in that Cloud HSM RPC endpoint, which is inside of our Postman terminal. And so that's this guy right here. So we want this portion of the string, right? These are the service IDs, our environment ID, our service ID, and then the RPC endpoint. And this should work. All right, let me just do my due diligence and make sure I have enumerated everything properly. Path to the file, method, argument, number of transactions, number of loops, number of workers, the account, and the endpoint that we want to use. Okay, well, what could go wrong? All right, good start. And again, this is kind of just proving the functionality that we have in Kaleido. It's not incredibly interesting if we're only using a single account and we're only using a single worker. This becomes a lot more interesting when we start thinking about horizontal scale and we start thinking about, needing multiple concurrent connections and allowing those objects to all get signed inside of a cloud utility, inside of a cloud service. Azure takes a few minutes to refresh, but one interesting thing to do on AWS, on Azure, on wherever, is to actually go into your Azure Key Vault service, click on the overview to look at the monitoring, and you'll be able to see 20 calls come in from Kaleido. So you as an operator, as an administrator, you have this fantastic oversight into, when these keys are being accessed. So you can create that, really, really logical mapping of your application drivers and the access of your keys. And you can immediately identify if, those keys are being accessed in some malicious manner, or if there's some, buggy implementation in your application. So I think we put metrics and monitoring on this call. So just to do justice to that, we'll go ahead and hop over to Kaleido version 2, which is our fantastic update to the Kaleido console. And we can just look at our health and monitoring, and we can see, the existence of, our entire environment here of the CPU, of the memory, of the disk. We can go into our data explorer and we can look at our dashboard for our block explorer. We see that we just injected, an instantiation of a smart contract and then 21 subsequent transactions against it. We can see kind of the total number of transactions that we have here. We have 22, remember, because we use the REST API gateway to instantiate the original simple storage. And then we have really nice line of sight into, where these transactions came from, who signed them, whether they were, calls to a smart contract or whether they were deployments of a smart contract. And we can even see, if we click on a specific transaction, we'll even be able to see, well, let's click on our original one here, our smart contract deployment. I think it was this one. Okay, well, if we were to invoke the method, then we'll be able to see the actual method and the arguments that are passed to the method as well. But really, really nice holistic line of sight into your overall environment. And then you can dive even, deeply into specific nodes as well. So you can look at, the health and monitoring of your runtimes, looking at your system monitor, looking at node 1, node 2, node 3, and understanding, even the consumption of your, HSM service as well. So let's hop back into our Azure portal, and let's see if the metrics updated yet for our Key Vault service. Yeah, so pretty cool here, right? So we did 10 transactions and 20 loops. So we can see here that 20 requests came in from Kaleido into our Key Vault. So again, as an operator, and you can even see the success ratio as well. So as an operator, again, in your Azure administrative portal, in your Kaleido administrative portal, you have, really, really fantastic line of sight into the health of your blockchain network, and kind of the access of, the backend keys that are being used to sign transactions. So hopefully that was interesting. It's very, very interesting to me. And I've seen a lot of different blockchain things. This is something that really, really gets me excited in the sense that, this is a huge requirement that is, a big blocker for a lot of enterprises and a lot of industries to have the confidence, to use blockchain. They don't want the overhead of, having to become blockchain experts and, create, Web3 based applications and do external signing. But they also, need the assurances that if something is going to be signed ostensibly on the server side, that it can actually be delegated into a piece of hardware that they control with their own private cloud organization. And that's what this feature gives you. And it's not segregated to a single cloud. I really want to reiterate that. We showed Azure today. The same functionality is available on AWS with their cloud HSM. And perhaps most excitingly, though, HashiCorp extension is available, meaning you can run that server wherever the heck you want, on premise, in your own private cloud, etc. Okay, thanks for that, Zach. Zach said that was great. Yeah, that was good for me too. So I'm going to stop there. If there's any questions, I'll drag my feet here for 30 seconds or so. But in the meantime, I'm just going to chuck my email into the chat. If anyone has any technical or commercial questions, please do not hesitate to reach out to me. Something that we didn't touch on that was inside of the slide deck is that Kaleido is a really, really flexible platform. We've looked at all the functionality, but in terms of helping you get from the initial stages of your project into production, we have a bunch of different pricing tiers and even bespoke packages with huge discounts associated with them to let you, affordably build out your MVP using services such as this, using other cloud integrations, and using large size nodes that'll support throughput. So if you guys want to, discuss a use case or discuss, any technical or financial considerations in more detail, please reach out to me. Don't hesitate to go ahead and sign up for a Kaleido account. Absolutely free to get started. And if you're inside of the product and you do have a sales inquiry or you do have a product inquiry or you think you found a bug, feel free to use our ticketing system and submit a ticket. This is actually fantastic because our entire team has line of sight into this. So I'm of course always available, but the product is free to get started with, and our team is available to help. So thanks a lot, guys, for attending. This was a nice turnout today. We will continue to keep looking at interesting features. We have some really more exciting stuff coming in Kaleido, and our version 2 of the console is reaching kind of the end of it's reaching the finish line here. So you'll be able to get all of the features that you've grown to know and love, hopefully on what I'm calling Classic Kaleido on version 2 of the console. All the APIs, of course, are still they're still there behind the scenes. I think that's one thing I forgot to mention today, but hopefully that was kind of intuited, since I was, simply using a Postman terminal to do all these configurations. But I'll end by saying that everything in Kaleido is accomplishable with an API, whether it's a contract, whether it's a service, or whether it's an admin operation. So thanks again, everyone, for attending. I really hope everyone's staying safe and staying healthy, and really looking forward to us getting all of this COVID behind us, so we can try to regain some of the momentum that has existed with a lot of these blockchain projects. So thanks again. Reach out via the support ticket or directly to me, and happy to talk. Everyone, have yourselves a fantastic Cinco de Mayo. Thank you.